As a former NFL defensive tackle, Brandon Noble has dealt with more than his fair share of physical injuries.
Over the course of playing football for as long as I did, you get dinged up. And I've separated my shoulders. I've had more concussions than I'd like to know about. Broken both my hands, I've broken a leg.
But none of these football injuries could ever come close to the kind of physical threat Brandon would eventually face. That's because during an operation to repair one of his injuries, Brandon came in contact with a more formidable opponent than any he had faced on the football field, a drug-resistant bacterial infection known as methicillin-resistant Staphylococcus aureus, or MRSA.
I was playing for the Washington Redskins. I was going into my 6th year in the NFL. I popped some cartilage loose in my knee and had to go get a debridement, just a routine scope washout. 8 days post-surgery, they took the stitches out, and that night I had a hot spot flare up over one porthole. My knee felt like it was being lit on fire. The doctors had admitted me to the ER, and an infectious disease doctor came in. 48 hours later, the doc says, if you'd have waited another 24 hours, this would have potentially killed you, or you would have lost your leg.
The only effective treatments against such a severe bacterial infection are antibiotics. But Brandon's infection was resistant to the most commonly used medications. Each time one antibiotic didn't work, the only solution was to take a stronger one. Brandon quickly learned that the side effects of these drugs can be nearly as hard on the body as the actual illnesses they are designed to treat.
All these antibiotics take a toll on you. They affect your insides. Not only are they killing the bug, but they're killing the natural bacteria inside your body.
Antibiotics, most notably penicillin, became widely used during the World War II era. The discovery was hailed as a medical miracle, saving countless lives and easing the complications of many feared diseases and infections. But in 1943, just 4 years after drug companies started mass-producing penicillin, infectious bacteria began to appear that were resistant to this treatment. Today, after more than 50 years of widespread use, antibiotics no longer perform as they once did. But to truly understand the problem of antibiotic resistance, it is first important to understand what antibiotics are and the role these drugs play in fighting disease.
Most of the drugs we use are antibacterial to deal with bacterial infections, and they basically either inhibit or kill bacteria and allow the body defenses to mop up the remaining infection and cure the patient.
The striking thing about bacteria is that they can multiply as often as every 20 minutes. Antibiotic resistance happens when bacteria develop mutations, which allow them to resist the effects of a particular medicine. In a large population of bacteria that are mutating all the time, a few will be resistant to an individual antibiotic. So, while the antibiotic kills off a large number of those bacteria, say 99.9%, it can't kill that small 0.1% that are resistant. It is this resistant bacteria that will then keep multiplying, and before long, a new population of antibiotic-resistant bacteria will exist.
A main driver of development of resistance is overuse of antibiotics, actually. And so that's why trying to use antibiotics judiciously or the right way makes a difference down the road, so bacteria don't have that chance to learn how to be resistant.
As a professional football player, Brandon was in his physical prime, tough enough to tackle the strongest NFL player. But this resistant bacterial infection ended his career and nearly ended his life.
I was at my peak physically, health-wise. I was in shape. I, a professional athlete. And it knocked me down. It floored me, and it almost killed me.